us a couple new types of functions. Right now I'm looking at the greatest integer function, which is also known as a step function. And this is the notation right here. F of x equals your step function of x is the greatest integer less than or equal to x. So there's a step at each integer. And you can see why it's called a step function. I mean, it looks like a bunch of steps. So we're going to do this. We're going to compare the graph of f of x equals a step function x to the graph of g of x equals x, which this is just a straight line with a slope of 1, y-intercept of 0. So this would be my g of x that they want me to compare it to. And if we're going to compare it to that, you've got steps, meaning that we want the greatest integer, like the greatest whole number that's less than or equal to the x. The x value -4, the greatest integer that is less than or equal to -4 is -4. So that means my y value has to hit at -4. And you can see this closed dot here. And then as I slide along this graph, it goes to a bunch of decimals, like it hits these x values, everything until you get to the -3. And all those decimals, we want the greatest integer that's less than that. So for everything in this section, the greatest integer that's less than that is still down here at -4. So that's why it's got this line, this step. And as soon as you hit the whole number again, so as soon as I hit the x value -3, okay, then I get my dot there, and then it's going to keep at -3 until I hit the x value of -2, and it jumps up again. So you've got all these steps. The open dots right here mean that's where you kind of jumped up to the point above it. So the open dot means it doesn't actually hit that particular point. It gets really close to it, but it doesn't hit that exact point. So open dot, and then it jumps to the point right above it. Close dot. And you got your step. Open dot doesn't hit that exact point. It hits the point right above it. This is our step function, or our greatest integer function. And we're going to go on to the next one where it asks you to graph h of x, which is another step function of 2x plus 1. It's not just a plain x, it's a 2x plus 1. So I'm going to graph the line of 2x plus 1. Okay, so the y-intercept is at 1, and then I've got a slope of 2, so like up 2 over 1, up 2 over 1. So here's our line, and in order to get the step function in that line, I'm going to have to do close dot, and then I step over, and then open dot, where it will jump up to the next integer. Because notice that this section is not in any integers. This is all at like decimals and fractions, messy numbers, right? Once it gets up to an integer, I put a closed dot there, I hit that, and it'll stay in that step until open dot, until it jumps up to the next integer. So this integer is -2. Step and then open dot, it jumps up to the closed point there, and you have a step until it jumps up again. I'm sure you're kind of seeing the pattern here. It's going to be the same thing over and over and over again. But as far as my graph goes, the purple one here, so I'm going to erase the blue straight line. The purple one is my step function. That has to do with this notation for a step function. And it would continue. I can't even see the line right now, but I can keep the pattern going. So I have my step closed dot over to an open dot, and it looks like it's jumping up to closed dot over to an open dot. So I can see my step function. Okay, so this is, again, greatest integer function or step function. I don't know which term your book is going to use, but they're talking about the same thing. And our other new function is a piecewise function. So piecewise means that you have more than one piece. In this case, we have 2 different pieces. And you can see those are the 2 different straight lines that you've had to graph. And it is broken up based off of your x-axis. So here's my cutoff at 2, the x value 2. All the x's that were less than or equal to the 2 was this x plus 1 line. So this right here was this section. And then everything that was greater than 2 is that green section. That would be this other -x plus 4 line. All right, so let's see if we can draw our own. I'm going to, first of all, draw my x and y axis, and then I'm going to have to break my x axis up into, in this case, I have to break it up into 3 different pieces. So this first section right here is for all the x's that are less than -1. So here's where my x is a -1. So it's going to be, I'm going to put an open dot there. It doesn't actually hit the -1. There's no equal to bar. It's going to be everything less than the -1. And then everything from -1 to -2. And again, there are those little bars that's including the -1 and including the -2. So everything from -1 x value to the x value +2, everything in this section right here is going to be that middle function, the x squared function. And then the last one is for everything greater than the x value of 2. So from 2 on will be this -1 function. Okay, so I haven't graphed it. I just kind of broke it up into 3 different sections. So let's see if I can graph it. My blue one, my first one here, was the line -3x + 1. -3 is my slope. It would hit the y-axis at a +1, but I can't have the graph in that section. So let's get a couple other points. At x value -1, I get a y value of 4. 1, 2, 3, 4. So I hit that point and I want an open dot at that point. My slope was -3. So if I go 3, 1, okay, so here is my straight line. It does go forever to the left because it's all the x's less than -1, like forevermore less than -1. So I'm going to erase that. It's that whole section to the left of the x value -1. So now the green one has to be between the -1 and 2 with closed dots on both. This one says we are using the x squared function, which at -1, -1 squared is 1. So I will put a closed dot there. And it's a parabola. So I'm going to make this parabola go to +2, which 2 squared is 4. 1, 2, 3, 4. Okay, and a closed dot there because it was the equal to, had the little equal to bar here on both of those, so closed dots. Okay, so here's my parabola just in that section from -1 to 2. Okay, so I'll erase that. And then this last section is going to go from 2 to infinity, and I need the open dot. It's not equal to, it's just x greater than 2. And it's a constant function. It's going to hit the y value of -1. I'll get -1 and it'll hit that forever. So I'm going to get rid of this one. Okay, so there are all 3 of my functions broken into the 3 different pieces. Open dots when I did not have the equal to bar, closed dots on the green one that does have the little equal to bar. We've got a piecewise function, and next we are looking at even and odd functions. It says an even function is a function whose graph is symmetric with respect to the y-axis. So here's my y-axis right here, and it's symmetric, like I could fold it in half over the y-axis and both sides would totally match up. What that means as far as your xy points go, it means your y values are the same y values, but the x's have a different sign. So like this is the point 1, -1, and this other one is the point -1, -1. The y values are exactly the same, but the x values had their sign change. Those are even functions. The odd functions says symmetric to the origin. What that means is, here's your origin, 0, 0. It's like you can rotate 180 degrees, like half a circle around the origin, and then you'll get the next point. And if I rotate this one 180 degrees, like half a circle around the origin, it would get to the other point. As far as your xy points, what happens is you take the x and y and you change the sign on both the x and the y to get another point that's on that graph. So that would be an odd function. And then this one right here, the last one, it's symmetric to the x-axis, where your first one, the even function, was symmetric to the y-axis. This one that's symmetric to the x-axis actually isn't even a function. I don't know if you guys remember, we talked about the vertical line test. When you draw a vertical line, you have to hit at most 1 point. If you hit any more than 1 point, it's not a function. So this actually is not a function at all. It is symmetric to the x-axis, but it's not a function. If you need to go back and look at those notes or watch the video, go ahead and feel free to do that. We're going to see if we can graph some of these. So first up, it says to graph your own even function. I'm going to draw my x-axis, my y-axis, and if I want an even function, then it should be symmetrical over the y-axis. So maybe I'll do something like this absolute value function that got shifted over. Oh, it's supposed to be symmetric over the y-axis. So now I've got to make it look the same on the other side. So, okay, I'm going to go up to the 3. This is an even function. It is symmetric over that y-axis. You guys can come up with so many different options on this to create it yourself. So now I'm going to come up with my own odd function. Here's my x-axis, my y-axis, and whatever my odd function is, I should be able to rotate around the origin by 180 degrees and make it match up exactly the same. So I think I'm going to do just like a straight line. This is the line y equals x. If I rotated this around, so I'm going to pick 2 points here, 3, 3. If I rotated that 180 degrees around, I would hit this point right here, -3, -3. And if I rotated that 180 degrees, I would still get back to the same point. So this is an odd function. It's symmetrical around the origin. Okay, so again, there are many different kinds of even and odd functions that you guys can come up with on your own. So feel free to kind of play with that and see what you can come up with.